Hey Year 11 and welcome to the next episode of Mathematical Mowbray Movies. We're continuing on with our work on SOHCAHTOA. Sorry that this little joke's getting a little bit old. I really hope that you score as you work your way through the questions in this episode. Just a reminder, from the last episode we said that there were two different types of calculations that you could be asked to perform using SOHCAHTOA. And in the last episode, we looked at the first of those calculations. That was the calculation of an unknown angle. In this video, we're looking at the calculation of an unknown side. So this is this situation where you're given one side, you're given one angle, and you're asked to calculate the other side. Within these calculations of sides, there's actually a further two different types of setups that you'll encounter, and you need to be able to manipulate the equations to perform these calculations. So I'll explain what I mean. Like with the last video, we always start with these questions by labelling the sides in relation to the angle. So here's my angle of 50. This here is my hypotenuse because it's the longest side. This here is the side opposite my angle, so it's the opposite side. The next step, of course, is to work out which ratio to use. I'm interested in the ratio that's got opposite and hypotenuse in it. You might just need to write out SOHCAHTOA for yourself again, just to remind yourself of which ones involve which sides. I'm interested in opposite and hypotenuse, so I'm interested in sine. So I write out the ratio there. So sine of theta is equal to opposite over hypotenuse. Just like last time, I now substitute in what I know. I know that theta in this case is 50, so I'm going to write sine of 50. I know that my opposite side in this case is given by x, and I know that my hypotenuse is given by 20. So in this case I'm trying to find this unknown x, which is on the top of the fraction. You'll see how that's different in a moment to this situation here. In this situation I'm again asked to find an unknown x, given one side and one angle. I begin by labelling my triangle. Again, this is my hypotenuse. In this case, this is my adjacent side. I look at my formulas to see which one involves adjacent and hypotenuse, and it's this one here. So I'm going to use the cos ratio, that cos theta equals adjacent over hypotenuse. Again, I substitute in what I know. I know that theta here is 30 degrees. Notice that the angle always comes after the sine or the cos or the tan. I know that my adjacent side is 10, and in this case I'm trying to find my hypotenuse x. So here you can see in this case my unknown is on the bottom of the fraction, whereas in this case my unknown was on the top of the fraction, and that gives rise to two different ways of proceeding. Let's look at the first one. This is the same question but just with a bit more space for me to work on it, so I'm just going to put down the same point where we were up to. We just said that sine of theta was equal to opposite over hypotenuse, and that in this case sine of 50 was equal to x over 20. Now I need to get rid of divided by 20 to leave the x on its own. So I use the inverse of dividing by 20, which is of course to multiply by 20. So in this case I'm going to bring my 20 up and end up with 20 times sine 50, and that'll leave the x on its own. So on my calculator I just need to literally type that in. 20 times sine, no need for inverse or anything, just as it is, 50 equals. And it gives me 15.32 equal to x. I don't put it into degrees, minutes and seconds because this is giving me the length of a side, and of course the lengths aren't measured in degrees, minutes and seconds. So let's just do another example of a question here. So I'll just quickly put one here. So let's just imagine that this angle here is about 62 degrees. This is 4 and this is x here. So again, I'm going to go through and say I need to label my sides. So here, this side is opposite my angle, this side is adjacent to it. I need to work out which ratio involves opposite and adjacent, and you can see here it is the tan ratio. So I write out tan of theta equals opposite over adjacent. substitute in what I know. I know that theta is equal to 62. I know that the opposite side in this case is my unknown. I know that the adjacent side is 4. Again, you can see that the 4 is on the bottom of the fraction, so I move that up by multiplying. So 4 times 10, 62 will give me x. So again, I just type that in. 4 times 10, 62 equals, in this case, 7.52. That's my first scenario, and I just want you to have a quick go at one question for yourself. So have a go at this one. Determine the length of the unknown side, and just put your answer in the box, of course. Or make sure you select it. Alright, I'll just quickly go through this for those people that are interested. Of course, you can skip through if you don't need it. So this is, again, I'll do it quickly, my adjacent side. This is my hypotenuse. I'm going to use, therefore, the cos ratio. Cos of theta is adjacent over hypotenuse. My theta here was 42 degrees. My adjacent side is my unknown. My hypotenuse is 12. I bring this up by multiplying. 12 times cos 42 equals x. On my calculator, 12 times cos 42 equals 8.9. I'm going to round it up to 8.92 equals x. Hopefully you got it right. Alright, the next scenario is if the unknown side is on the bottom of the fraction. So this was the same as the example that I gave before. So let's just do the setup again. Label my sides first. This is my hypotenuse. This is my adjacent side because it's next to it. Adjacent hypotenuse, which which ratio do I need to use? Hopefully you can remember, SOHCAHTOA if you can't. Adjacent and hypotenuse, I'm interested in these ones, so I'm interested in cos. So I write out my ratio. Cos of theta equals adjacent over hypotenuse. So again, I substitute in what I know. I know that theta is equal to 30. I know that my adjacent is 10. And I know that my hypotenuse is the unknown. You can see here that my unknown this time is on the bottom of the fraction. And when it's on the bottom of the fraction, we do this little tricky switcheroo. So we actually end up swapping the x to the top and swapping cos 30 to the bottom. So this ends up with x equals 10 over cos 30. Now the reason we do that is it's like we're bringing the x up to the top by timesing by x, and then we bring the cos 30 down to the bottom by dividing by cos 30. But in essence what we do is we just do this little switcheroo. Then I just type it in on my calculator. 10 divided by, I always put in brackets for things that are under the fraction to make sure that you're right, or you can set it up as a fraction. And I get x equals 11 and this time again 5. I'm going to round that 4 up to 5 since the next number is a 7. Let's do one more example together. Again, label my sides. So this is the opposite side. This is the adjacent side. Opposite and adjacent, I'm going to need to use tan. So I write out the ratio. Tan theta is opposite over adjacent. Substitute in what I know. I know that theta is 16 because that's my angle up here. My opposite side is 7. My adjacent side is x. Again, you can see that the x is on the bottom, so we do our switcheroo. So x is 7 over tan 16. Again, I'll just plug it in on my calculator. No need for any of the inverse operations, of course. Remember that I generally put in the brackets, just to be sure. And I end up with 24.41 as my answer. Okay, can you please have a go at this question yourself? See how you go. Working out the unknown side. Alright, for those people who would like a quick explanation, and again I'll do it quite quickly. I label my sides. This is the adjacent. This is the hypotenuse, so I'm going to use cos cos theta equals adjacent over hypotenuse. I sub in what I know. The theta is 71. Adjacent's 3. Hypotenuse is x. It's the unknown. I do my switcheroo. X equals 3 over cos 71. 3 divided by cos 71 is 9.21. So x equals 9.21. Okay, hopefully you got that right. Last quick question that I'm going to get you to have a go at. Before I do, you're going to need some terminology. The first one is the angle of elevation. When you think of elevation, you think of things going up. And so the angle of elevation is the angle between the horizontal. Both of these angles are going to be between the horizontal. But between the horizontal and measured up, so that the line of sight ends up in line with whatever I'm viewing. So in this case, if I was viewing the top of the tree, the angle of elevation from this point would be this angle here, because it's the angle from the horizontal up. Now, the angle of depression, if you're kind of depressed, you're usually feeling a bit sad or a bit down. And so the angle of depression, again, measured from the horizontal, always from the horizontal, is the angle down toward whatever I'm viewing. So if I'm looking at the top of this mast here, oops, that was a pretty bad line, this would be my angle of depression. So both cases are from the horizontal, but this is horizontal up, horizontal down. So here's the question I just want you to have a last go at. I'll just move it there so you can see it all. So give that question a go. Okay, I'll just quickly go through it and check that everyone's okay with it. This says the angle of depression of the base of the tree from the top of the building 65 degrees. So it's saying that from this point here, the angle down is 65 degrees. It says the height of the building is 30 metres, and it asks you to work out how far away the base of the tree is from the building. So it's asking you for that distance there. Now, I always draw a triangle separately to the diagram that they give me because I get all a bit mixed up otherwise. So here's my triangle. Here's my right angle. I know that this here is 30 metres. This is what I'm trying to find, my x, because it's the distance. I need an angle here. I know there's sort of this immediate assumption that you want to make this 65, but you can't. You've got to remember that alternate angles, which use this Z rule, are equal, which means that this angle here is actually equal to this angle here. So this angle here is actually 65. So this angle here is 65. You could have otherwise used that this is a right angle, and you could have calculated this by subtracting 65 from 90, and you'd have an angle there in your case, and you'd do a slightly different calculation. Both is fine. In any case, I need to work out my answer, label my sides. So in this case, I've got, this is my adjacent side, this is my opposite side. I'm going to use tan because it's opposite and adjacent. Tan theta equals opposite over adjacent. Sub in what I know. I know that theta is 65. I know that my opposite is 30. My adjacent is x. My x is on the bottom, so I do my switcheroo. X equals 30 over tan 65. Whack it in my calculator. 30 divided by tan 65 equals 13.98 or 13.99. They ask me to give it to correct to one decimal place. So here I'm trying to give it to that first decimal. This 8 bumps that up, so it's actually going to bump that 9 up, which bumps the 3 up, which makes it 14.0 metres, which of course would be the answer B. So I hope you did score some serious goals with your work in that episode. Nice job.